Carol uses glues and blurpos to make zippies. His recipe uses 4 cups of glues and 3 cups of blurpos to make 60 zippies. He can also make larger batches of zippies using the same ratios. On Monday, Carol uses 28 cups of glues. When he makes zippies, determine the number of cups of blurpos that he uses. So for this question, I think the standard is 4G plus 3B, whereas G represents glues and B represents the blurpos, is 60. Z, where Z represents the zippies. So I think that's the sort of the standard equation, and hopefully that will help us. So for the first question, 28, so 28 of G. So basically I think what they're doing is they're just multiplying that by 7. And if you multiply that by 7, you get 28G plus 21B is 420 Z. So 28 cups of G makes zippies. They don't really mention how much, but we've calculated it as 420. And how many blurpos? Well, 21. So the answer to this question is 21. Part B. On Tuesday, Carol uses 48 cups of one of the ingredients and n cups of the other to make zippies. Determine the 2 possible values. So the ratio is 4 to 3, right? The ratio of these, the G to B ratio. But they don't tell us which is G and which is B. So first I'll just calculate that ratio. And when I do, I'll get n equal to 36. And the other way of looking at it is that the n is representing the G and the 48 is representing the B. When you calculate this, n will be, I believe, 64. So the 2 possible values of n are 36 and 64. On Wednesday, Carol uses 64 cups of glues and 42 cups of blurpos to determine the largest number of zippies that he can make. So, again, 4 to 3. Let's see if 64 is the G, and let's see what B is. If we do this, B is 48. But that's not possible because he only has 42 cups of B. So that is incorrect. So let's try the other one. 4 over 3 is G over 42 this time. We're saying we're going to keep this guy, but we're going to try to figure out how much of the glues we need. When you do this, you get G equal to 56. And that's entirely possible, so because we started with 64, so we certainly can use 56. So we have a situation of 56G plus 48B. And that, we have to figure out what that is. Well, if I factor out a 14, I get 4G plus 3B. And that is our magic formula there at 60Z, 4G plus 3B. So this is 60Z. And therefore, that's 840. So 840 zippies is what he can make. And part D, on Thursday, Carol makes zippies to sell. His only costs come from purchasing glues and blurpos. He sells each zippy for 50 cents and makes a profit of 30 cents for each zippy sold. Carol pays $1.80 for each cup of glues. Determine how much Carol pays per cup of blurpos. Okay. Well, the standard formula is 4G plus 3B, and that is equal to 60Z, right? So we all know the profit of anything is how much money we make, which is the revenue, and then minus the expenses. So I think that's what we have to look at. So the profit is 60. Let's just stick with this one. They don't actually tell me how many he's making of each, but let's just stick with that. Let's say he makes 60. The profit is 30 cents, right? So put that in there. And then the revenue, he's selling each for 50 cents. Is that correct? Yeah. So 60 times 50. And then the expenses, that I don't know. So I'll just call expenses E. So when I solve for E, I get 30 minus 18, 12. So $12 is the expenses. So I think that is what helps me figure out how much I am paying for the blurpos. Okay. So the expenses, E, is how much I pay for the glues, which is actually 180. They actually gave me that in the question. And then how much I'm paying for the B. Yeah, that I don't know. And I've calculated this with these numbers, so 4 and G. So 12 is equal to 4 times 180 and 3 times X. Yeah. And therefore, 3 times X is 4.8, and therefore X is 1.6. So 1.6 is the price that Carol pays per cup of blur pus. In figure 1, trapezoid ABED is formed by joining triangle BCE to rectangle ABCD. AB is 3, CE is 6, area of the trapezoid is 48. Determine the length of BE. Let's label this. This is 3, therefore this is 3, this is 6, and the height we don't know, so we'll just call it height. Area of a trapezoid is basically, in this case, going to be 3, which is the top, plus the bottom, which is 9, divided by 2, times the height. And they told me that's 48, I believe, yeah. So that's what, 12 over 2h, so that's 48 divided by 6, which I believe is, 48 divided by 6 is equal to 8. Okay. So, that means this is 8. And then therefore this is also 8. So what are they asking for? The length of BE. Okay, so the BE is the hypotenuse of that right triangle. Okay, so that's easy. So BE squared is just going to be 8 squared plus 6 squared. And therefore BE is 10. So just use the Pythagorean theorem for that one. Part B. In figure 2, circles with centers P and Q touch a line L at points S and T. Together they touch at X. Because the circle touches at X, the line PQ passes through X, so that PQ is equal to PX plus XQ. Because the circles touch at L at S and T, PS and QT are perpendicular to L. If the circle with center P has radius 25 and the circle with center Q has radius 16, determine the area of trapezoid PQTS. All right, let's see. This diagram's kind of small, but I'm going to draw a perpendicular, a line that basically forms a right angle. And let's see here. Let me see if I can label this. So that little guy there is 9, because the whole thing is 25, and from there to there is 16. So that little guy was 25 minus 16. That's why I put 9. That's 25, right? The radius? Yeah, that's 16. And, I think, anything else? I think that's all I can label. Now, what do they want? They want the area of that trapezoid, right? So to get the area of the trapezoid, I'm going to need to know the length ST. Well, ST is going to be the same as the length of this line up here. So that I can get with Pythagoras. Basically, the equivalent of ST plus that 9 squared is the 25 plus 16 squared, I believe, which is 41 squared. And when you solve for this, you get ST equal to 40. So now the area is just going to be 16 plus 25, which is the length from that side, and then over 2, and then multiplied by the height, which is 40. So that's going to be, when you crunch out those numbers, 41 times 20, so 410 times 2, 820. So 820 is the area of that trapezoid. Figure C is formed, part C, figure 3 is formed by adding a circle of radius r to figure 2 that touches L, and each of the 2 other circles determine the value of r. Okay, so we're going to need to blow this up here. I'm probably going to make it as large as I can. Yeah. Okay, so now I've got to carefully draw some lines here, because I need to illustrate what I need to do. So let's see here. So hopefully these lines will help, and let's see if I can label it without making the diagram too messy. The radius is r, right? So we'll put a little r there. It's going to be hard, but there's a little r in there. And then what else do I label now? Well, this from here to here, that is 25 minus r. And then from here to here is 16 minus r, I believe. And I think that's good enough. And those two triangles I'm going to draw again here just to avoid making that diagram too messy. So from here to here I'm going to call this x, and then from here to here will be 40 minus x. So this is the first guy is x 25 minus r, and then the two radii. So the first was 25 and then the next one is r. So there's a Pythagorean relationship. And then the other triangle, which is on the other side, that's also a right triangle. That's going to be 40 minus x, 16 minus r, and I believe the hypotenuse is the same. Or no. This hypotenuse is not the same. It's 16 plus r. But basically it's the addition of two radii. That's really what I was trying to say. Okay, so with these two, we can easily get two Pythagorean relationships. The first one will give me 25 minus r squared plus x squared is 25 plus r squared. And then the second equation will be 16 plus r squared is equal to 16 minus r squared plus 40 minus x squared. And what are we trying to do here? We're trying to figure out r. So r is our goal. So we have two equations, two variables, so we should be able to solve this without any real problem. I'm just trying to see what's the right way of going about this. I think just expanding it would do it. Yeah. Okay, let me just expand the first one. So 25 squared minus 50r plus r squared plus x squared. And then on the other side, 25 squared plus 50r plus r squared. So a lot cancels. That cancels with that. That cancels with that. So the only thing I left with is x squared is equal to 100r. And therefore x is equal to 10 root r. So that's very helpful, I think. X is equal to 10 root r. So let's expand this guy. So 16 squared plus 32r plus r squared. 16 squared minus 32r plus r squared. And then this one, I'm going to substitute this guy in. So it's going to be 40 minus 10 root r all squared. Okay, so this cancels with that. That cancels with that. This becomes 64r. Let me just see if I did this correctly. Yeah. And then this is 40 minus 10 root r all squared. Take the square root of both sides, and this becomes 8 root r is 40 minus 10 root r. And we obviously going to be working with the positive stuff. So this is going to be 40 is 18 root r. Root r is 40 over 18, which I believe is 20 over 9. And therefore r, if you square it, would be 400 over 81. 400 over 81 is the value for the radius of that small circle. Suppose that n is some positive integer. Alphonse and Beryl play a game. They take turns adding integers to a running total. Alphonse always goes first, and the beginning total is always 0. On turn k, the player whose turn it is may add to the running total any of the integers from 1 to k inclusive. The winner is the player who brings the total to exactly n. For example, if n is 10, this is how the game would proceed. For each value of n, no one player has a winning strategy. One player has a winning strategy. Okay, if n is 8, show that Beryl has a winning strategy. Okay. Well, do I really need to walk you through? Let me walk you through what's happening, I guess. So in turn 1, Alphonse, that's his turn, he can choose numbers that are from 1 to k, where k is the turn number. Got it? So on turn k, he can choose numbers from 1 to k. So on turn 1, he can only choose 1. On turn 2, he can choose numbers from 1 to k, and k in this case is 2. So that's why he can choose 1 and 2. On turn 3, he can choose either 1, 2, and 3, and so on. So they're saying he chooses the number 1, which is the only choice he has, and therefore the running total is 1. On the second turn, which Beryl gets to choose, he has a choice. He can choose either the number 1 or the number 2. He decides to choose 2. Now the running total would be 1 plus 2, which is 3. On the third turn, Alphonse, his choices are 1, 2, or 3. He decides to choose 1, and therefore the running total is 4. On the fourth turn, Beryl, his choices are the integers 1, 2, 3, or 4. He decides that he's going to choose 3. And then now the running total is 7. Alphonse is on the next turn, and he has a choice of 1, 2, 3, 4, 5. He decides to choose 3, and that brings it up to 10. And since n was equal to 10, Alphonse wins the game with this strategy, if there even was a strategy. So that's basically how the game goes, and now they're saying if n is 8, show that Beryl has some strategy. Okay, so let's just continue that table. We got turn number. What was the next one? Player. Possible integers. Feels like Jeopardy here. Choice and running total. Okay, so let's fill in this table and let's see what we get. So 1, 2, I don't know how many turns, but let's just say so far let's go to 5 turns. Now A, B, right? Alphonse, Beryl, and so on. So possible integers 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. So let's talk about this. So the first turn, there's only one possible choice, so not much really to decide there. That's the only choice that Alphonse has. Second choice. Beryl, this is where his strategy kicks in. He wants to choose 2. So that is what he does. He's going to choose 2, and therefore the running total becomes 3. Now Alphonse, at this point, has 3 choices, so he could choose either 1, 2, or 3. Now if he chooses 1, the running total will be 4. If he chooses 2, the running total will be 5. And if he chooses 3, the running total will be 6. Now whatever happens, Beryl now can win. Why? Because he wants to just get to 8. So if the running total was 4, he just has to choose 4. If the running total was 5, he just has to choose 3. If the running total was 6, he just has to choose 2. And in all scenarios, the running total will be now equal to 8, and that will allow him to win. So his strategy really was on the second turn, make sure you choose a 2. And then regardless of what Alphonse chooses on the third turn, he can win by adding to the running total to get 8. Part B, if n is 17, determine which of the 2 players has a winning strategy. Okay, so now we've got pretty much the same story, but now n is 17. So let's see what we can do here. Okay, so let's see here. Okay, so again, I have no idea how long this is going to go, but 17, so maybe a little bit longer than the previous one. And this is going to be same A, B, A, B, A, B, A. And this is the same. 1, 1, 2, 1, 2, 3. And you guys understand by now how this works. And let's just fill this in. 1, 2, 3, 4, 5, 6. And the last one would be 1, 2, 3, 4, 5, 6, and 7. Okay. So on the first turn, we don't have much choice. That's just going to be a 1, and the running total is 1. On the second one, we do have a choice. And who are we actually concentrating on? Determine which of the... Oh, there is nobody. We have to figure out... Because that question, they said Beryl, but this one, they're not saying anybody in particular, so I got to figure out... Okay, so it's sort of up to me. Okay, so... Well, I guess I have to look at everything. If I have 1 or 2, because I don't know what the strategy could be, this running total would be the 2 or 3. And I think Alphonse, if at this point, if he decides to choose a 3, the running total becomes a 5, and he decides to choose a 2, the running total becomes a 5. based on what the running total was previously. If it was 2 previously and he chooses a 3, it becomes 5. If it was 3 previously and he chooses a 2, it becomes 5. And I think he can be in control here. Let's see what happens, and then if he's not, we'll try for Beryl. So we're going to try Alphonse being in control. Because see, yeah, let's try for that. Okay, so then B, since B, we don't have to look at everything because we are sort of concentrating on Alphonse for now. Let's see what it is for all the choices. 6, 7, 8, or 9 will be the running total depending on which one of these numbers he chooses. Now, Alphonse, who's sort of like in the driver's seat, he decides to make the total 10. And he can do that by choosing either 4, 3, 2, or 1, depending on what the running total is. And then Beryl, again, we have to look at everything. So if he chooses those numbers, the running totals will be either 11, 12, 13, 14, 15, or 16. And now Alphonse can win. How? Because he wants to get to 17, and he can get 17 by choosing either 6, 5, 4, 3, 2, or 1, depending on what the previous running total was. So this strategy will help Alphonse win when n is equal to 17.